try and recap a little bit because yesterday's video was mute.
Okay, so yesterday we looked at a new inverse function. Alright? This is an exponential function, and we discovered that if we transpose x and y, for instance, if we're at 0, 1 for our exponential, then 1, 0 would be its inverse. If we're at 1, 2 on our exponential, then 2, 1. I'm going to write these down. So 0, 1, and 1, 2. What's our point? When we go 2, when we're dealing with the base of 2, then we would go up 4. Right? So when I transpose this point, this is going to be 4. 2. So 1, 0, 2, 1, 4, 0. There's our function, our inverse function. How do we write it? How do we write it, guys? We had y is 2x, right? We transpose x and y, got x equals 2 to the y. You guys remember, I know it's a little bit weird. You guys remember what we did next to solve for y? We did something to each side. Normally, if we have a square, we would square root. So instead of putting a square root on both sides, we put a b-box on each side. But this time, we don't need it to be a b-box. We know what the base is 2. We're going to put a 2-box on each side. So I put a 2-box on each side. And that cancels this, and I just got y equals 2-box x. And we learned that 2-box is actually a logarithm. We could write it as a logarithm. So log base 2x equals y. So that's the inverse function. My inverse function is log base 2. 2 times y. Right? Let's play with it a little bit. All right, log properties. Let's turn our log properties into our b-box properties into log properties. So just like I said previously, b-box is just log b, right? So if I rewrote that, log b is my b-box. This part is my log base b, and it would just be log b to b dx equals that. If logarithms are exponents, isn't b my base? Isn't x my exponent? Doesn't that equal dx? Right? It's kind of hard to do it when you've got variables instead of numbers. So try this one. I'm just going to change this to be a log b. Look at this property. Log of base b. If I get 1, it must be a 0, because b, base b, to an exponent 0 is always 1. Right? Last one. Log base b. So log base b to the b equals 1. Reasoning? A base of b to the exponent 1 equals b. This one actually looks very, very, very similar to the top one. Let me show you why. This one and this one really important property. We're going to use it over and over and over again. Whenever you see a B to B, it's always whatever that exponent is. See how these match? They're inverses of each other. E to the 1 is right? Just as with an X, it's just given if dx equals dx, right? Those are important properties. We're going to work with them over the next 3 or 4 days. Let's talk about that for a second. I'm going to pause the recording. I guess it's going to be back to the phone. Okay, so tomorrow we're going to work more with logs. Then Friday we're going to have a quiz. It's going to be an independent quiz. It's not going to be a group quiz. It'll be a quiz. Then next week, Ms. Liz and I are in Oakland for a conference for 3 days. Okay, this is not like free time because we've got to keep on schedule because the teachers are expecting us to stay ahead of them, right? So we have to teach on Monday and Tuesday. So what we're going to work on Friday, we're going to work again on Monday. So it'll be a video that you guys are going to watch. You'll come in, you're going to do a puzzle. We're going to start the puzzle today. You'll do the puzzle again on Monday, and then you're going to watch a recording of us, and then it'll say, pause the video here. And then you'll do the work, and then you'll start the video, and then you'll see if you got it right. And we're going to do that over and over again and give you time to work on your homework in class. Okay? And then we'll have Dylan here to help with homework and to help with us. Tuesday is going to be the same thing. You're going to come into a puzzle, then you're going to watch the lesson, and then you're going to work on your homework in class together. All right? Wednesday, you're going to take a group quiz. What normally comes after the group quiz? The test. So you're going to take the group quiz on Wednesday. I'll be back on Thursday. We'll go over. I'll have it graded before I get here. I'll grade the quiz. We'll go over. I will grade the quiz. We'll go over the quiz Thursday. That'll be the first time you see me. Thursday for the whole week, and then you will test the next day. So, is there room for you guys to mess around on Monday and Tuesday? Not at all. So we're keeping the lesson short so that you can work together and figure stuff out and rewatch things. Our videos will be posted on YouTube as well. Okay? It's totally doable. But you gotta stay focused. Okay? You can do it. You gotta stay focused. Alright. Fantastic. So using, I guess, my whole plan is we're going to be using these properties over and over again and whatnot. That's why we're trying to do. Alrighty, so I think you guys did the homework looks pretty good up here. I'm going to go over it right now. We kind of looked at some of these yesterday. Let's do this one. Okay, to evaluate this, all I have to do is change it into exponential form. By the way, you guys, sometimes when there's a base normally this would be written like this. Whenever there's a base of 10, it's never written there. I don't know why it's written there. Okay. It's just like this. If you see this, what's this number right here? That's 2. It's like a default 2. Square root. The only time it's not a square root is when you put a different number there, right? This is the same deal. Whenever you see a log that doesn't have a base, it's always base 10. So what is it like this? Why is it 10 in the base? Yeah, it's got it, yeah, because of, yeah, it's got to be, there's got to be a better reason than just scientific stuff. Let me come back to that question. Okay? Alright, so, log base 10. So, I'm going to turn this into exponential form. Log are exponents, right? So, log with a base of 10 to the exponent of 1 equals exponent plus 1. It looks so complicated, but it's not. It's just that the base, which is 10, to the first power is going to be the answer. So with this one, all I have to do is solve for x. So I subtract 1 from both sides, and I get x squared equals 9. If I take the square root of both sides, 2, plus or minus 3. Plus or minus being because if I put a 3 in there and square it, I'm going to get 9. If I put a negative 3 in there and square it, I'm still going to get 9. Okay, good. Now this is where it just gets a little bit tricky. In this case, it works. The plus and the minus works. So if I put back in here, 3 squared plus 1, I get 3 squared plus 3 squared is 9, plus 1 is 10. If this right here was 10, then it would be saying 10 to the 1 is 10. Is that true? So that works. Let's try negative 3. If I put negative 3 in here and square it and add a 1, don't I still get 10? That works. If this wasn't a square, and I said my answer is negative 3, x is negative 3, and x is positive 3, if I put a negative 3 in here, and I add 1, I get a negative 2. Anything to a power is never going to be negative. So sometimes when you get negatives down here, you got to go back up there and check and make sure they work. Okay? All right. We'll go back to that. You're not going to see too much of that. Let's look at this one. This one's pretty straightforward, right? X cubed equals 64. Where does X have to be when I cube it to get 64? Or I could have done it mathematically. I could have just thought about it intuitively, or I could have cube rooted both sides. So if I take the cube root of both sides, I get x equals 4. Okay, thumbs up, thumbs down. How are we doing so far? This is all review. I just want to make sure it was on the video. Okay, so since you've got that little bit of review, we're going to take 10 minutes for you to do this puzzle. So the puzzle is like this. There's these triangles. You've got to match them sides of the triangle. So let's look at this triangle. It's got the square root of 49. So I know the square root of 49 is 7. So I go look for a 7. I don't see a 7 anywhere. So that means it doesn't have to be a triangle when you put all these together, but this one it happens to be. It could have been like the side, like the edge, right? That could be the edge of my big triangle, right? It's got double triangles in here. What about this one? Let's just start at 64. 8. I see an 8 right here. So I'm going to take my puzzle piece and I'm going to turn it around so that I can match up those sides. That's what you're going to do with your puzzle. Okay? Now, here's an example puzzle piece, and I'm going to set you on your way. So here's a sample puzzle piece. Log 2 to the 16 equals what? You don't know. Alright? You can use a line, you could use an X, or you can use a question mark. Doesn't really matter. Right? We don't know. So I know that 2 is my base. I'm going to rewrite it into exponential terms. 2 is my base. My exponent is question mark. I don't know. But I know as soon as I take it to the exponent, it's going to be 16. Okay, so way back in the beginning of this unit, this is where we started. You guys remember that? We were solving for x using exponent rules. So how could I make these common bases? How can I make them common bases? I could change the 2 to a fraction if I wanted to, or I could change the 16 to a what? How can I have common bases? I would want to make this 2 too. Okay, let's do that. Because 2x equals 1 over 2 to the what makes 16? 4. But I still don't have common bases because this one's in the denominator and this one's in the numerator. So how do I change this one so that it's in the numerator? Change the exponent to negative. I'd go find -4, and I would match it back up right here with my piece, and this would be x, -4. And then I'd find another piece, and I'd put it together. So I'm going to give you 10 minutes. You're going to get as far as you can. Then on Friday, I'm going to give you another 10 minutes. You're going to get as far as you can. Then hopefully by Monday and Tuesday, you guys will be able to finish this puzzle in 10 minutes like that. Okay? All right. So you've got puzzle pieces in your two sets. So pair up with each other. Don't look at one table was looking at one, and we have a red and a yellow set. And you're trying to find the answers on the yellow set to your red set. I know, but it happens. Okay. So if you have a yellow set, then that yellow set is all your yellow pieces that are going to fit into a puzzle. Okay? If you have a red set, all the red set is going to, and that's going to make a triangle. Okay? All right. Get to work. We'll do that again Friday. Quickly, guys, quickly. I want to get through this, and I want you to have time in class to do homework. Quickly. I know you don't, it's hard to put a puzzle away, especially when you spend all that time for it. Okay. In 5, 4, 3, 2, 1. Okay, so we talked about this on Monday. We said that as I put bigger and bigger numbers in for x, things approaching 2.7 or people would say 2.7. We call that E. So E, since E is approximately 2.71, E happens to be, E dx happens to be in between 2 to the x and 3 to the x. And you should recognize these exponential models, right? 2 to the x is one of our most basic exponential models with a base of 2. 3 to the x just with a little bit more cheap. What about this one? What happens to the x? It's decaying, right? It's got the exact same shape. It's just decaying instead of growing. Good. All right. So that being said, let's look up here at our model and talk about what happens when we find the inverse function of e to the x. So again, just like all of our our exponential models, they all start at 0, 1 unless they have some type of transformation, right? So then when I put in 1 into e to the x, e to the 1, I get 2.71. So that's about 2.71 right there. Well, just like I did in my other graph, so I want to find the inverse function. Wouldn't I just transpose 0, 1 and 1, 2.71? If I transpose those, I get 1, 0 and 2.71. So 1 0 here. I put in 2.71. I really don't need any more than that. Okay? Now, what do we call this new function? Okay, let's transpose x and y. From our original y equals e to the x. We're going to do just like we did when we first came in today. Y equals e to the x. Transpose x and y. How do we solve for y again? E-box, right? But when we had 2, we called it a 2-box. We're going to call it an E-box. I like it. E-box. So I'm going to put an E-box on each side. So an E-box F equals an E-box e to the y. These are inverses of each other, so they cancel. And I'm left with E-box x equals y. Okay, E-box, don't know why.
It's for each.
Yeah, that's for each. You get this on, this is called the natural law. And not only does it get its own Phillips, but you no longer have to write the subscript. It is like special. So don't just really think it's ln. All the ln means is just the natural laws, which means it's law of safety. In fact, when I see this, I normally will like put a little thing here to remind myself that there's a mean, or at the beginning when I first started doing laws, I would just change it back to this. So it has all the same properties. It's the same exact thing. It just, for some reason, mean is that special. But it gives its own notation. Okay, so we're going to play with this a little bit. With the homework class we were supposed to do last night. This is our teacher. All this is I just wrote all of them out. All pretty. Yeah. So pretty. Okay. Before I go there, I'm going to talk about domain and range. This is on your homework thing. Alright, so for this exponential function, let's talk about the domain. The domain is usually always from infinity to infinity, unless there's a limit. Unless there's somewhere that this graph is going to stop. Right? We don't ever see it stopping unless we have like asymptotes or something. There's something to make it stop. So let's look at it. If we're looking at the domain, I'm looking at the blue graph, and if I'm going in this direction, is there ever going to be anything that makes that arrow stop from going on and on and on and on and on? Is there ever anything? Nothing. So it's infinity. If I go this way, is there anything that's going to make this arrow stop from going in this direction? It's just going to keep going in this direction, right? Infinity. Let's look at the range. Let's look at the range. As I'm going up, what if I change my color? Let's call the color underneath it. We're still on blue. We're still looking at this blue function. Alright, on the blue. As I'm going up on the y-axis, is there anything that's going to stop this arrow from keeping going in the upward direction? If I'm going down on the y-axis, is there anything that's ever going to stop this graph from going any further down? Yes. What stops it? A restriction. What's the restriction? Right here, right? 0. It stops at 0. So it stops at 0. Or I could write it, y has to be greater than 0. So it's the inverse function. I'll write it out again. X is infinity, negative infinity, and positive infinity. Look in this direction. As I'm going on the x-axis, is there anything that's going to stop that arrow from continuing to go that far in this direction on the x-axis? No. Go in this direction. Is there anything that's going to stop this arrow right here from going past here? Yes. Is it ever going to go cross over this line right here? No. It's never going to cross over. So it can never get smaller than 0. Right? You have to put a restriction in decimals here, right? So I could say it like this, or I could say x has to be bigger than 0. Let's look at our y. Anything a trend here? Pattern? Yes? On y. Is there anything that's going to stop this arrow to keep getting bigger and bigger and bigger going in this direction? Is there anything that's going to stop it? No. Is there anything that's going to stop it as I'm going down? No. So I have no restriction. Okay. We keep going back to the domain and range. So I think another project where you guys are using restrictions would help you guys get into domain and range. Okay. So let's go back to okay, so let's go to this one. This is the last 3 ones on your homework. Alright, so I see ln, so what am I going to change that to? let's change it to log e. So this is actually log e. The 2x is equal to 4. Logarithms are exponents. So e is my base. What's my exponent? 4 equals 2x. How am I going to solve for x? How do I get x by solve? It's more simple than that. Divide by 2. Right, guys? You should do the easiest thing possible, right? You can complicate things all over the place, but sometimes it's right there in front of you. I just divide everybody by 2. Okay, let's practice this. This is where you have to use the calculator. So x, what happened? There we go. So x is going to be approximate because we're talking e, right? We're going to do a decimal. So x, let's put this in a calculator. Everybody try and put in a calculator and let's see what we get. There's an E button. It's under the LN button.
Wait, but it's a second.
You have to hit second, then LN, and that'll give you an E with a little caret symbol.
The E is under LN.
Second element.
E is above LN.
What's under above?
E is above. Look at LN and look above it. It says E. So if we put that in, we're going to put e to the 4th, close parentheses, and then you're going to divide by 2. And you should get, we're going to go to 2 decimal places, 27.29, but then it's 9, so I changes this to a 0 and this to a 3. So okay, let's do it. And I got to do one more thing. So I'm going to put an LN again. So I'm going to change it to a log base e to 3x equals 5. So logarithms are exponents. So base e, what's my exponent? 5 equals 3x. How do I solve it? Divide by 3. And I have x is approximately whatever it is. If you're not getting this, we need to stay on the school so I can show you how to use your calculator. What do you have? 49.47. Is what you should get. You should. I wanted you to round it to the 100th place. So 49.47. That's the 100th place right there. 100th place. The other one was 299. So the 9 turns this one into a 10, which turns this one into a 3. Okay, moving on, guys. That was last night's homework. Here's your new stuff. It's not that much that's new. It's just manipulating. It's just changing things into an exponential form and then solving. So, remember I told you if there's nothing there, what's the base? 10. Okay, I'm going to do this first one. It says, if I have f of x equals log base 10x, find the following. What if x was 1,000? So I just substitute. This is a y, right? Y equals log base 10 to the 1,000. Logarithms are exponents. So my base is 10. My exponent is y. Logarithms are exponents, right? Equals 1,000. I need the same base. How can I change this? 10 to the what would make 1,000? 10 to the 3. So I've got common bases, so I can compare it. Y equals 3. Pretty easy? Let's try this one. 110. How else do we know how to write this? How do I write 0.1?
Over 10.
Okay, but if we didn't know that right away, which is the way I would write it right there, then we could have said, oh, that's 10%. Right? Oh, is that going to help me? No, let's rewrite it again. 10 per 100. Is that going to help me? Good. All right, so let's substitute in 1/10. So I have log, or we have y, sorry. Y equals log base 10 to the 1/10. I'm going to change it to exponential form. 10 is my base. Y is an exponent. It's equal to 1/10. Put that in the numerator, it will be -1. I have one more hard one to do. Y equals 2. Basically, tonight's homework is just taking what you already know how to do, taking last night's lesson and turning it into what you already know how to do. Here's the hardest one. You're going to get something like this. Okay? So y equals log to the 1/2, right? Or base 1/2 to the x. My x is 2 root 2. Let's change this stuff. Y equals log 1/2. How can I rewrite 2 root 2? There's a lot of different ways I can do it. I can write it like this. Is this 2 to the 1? And what's this? 2 to the left. What? 2 to the half? That's the same thing in exponent? Isn't 1 just 2 over 2? So when I multiply, what do I get?
1.
What's 2 halves and 1 half? Look at 3 halves. Right? That's one way to look at it. I also could have looked at it like this. If I stuck that one back inside, what would it be? A 4? So 4 times 2 is 8. Isn't 8 just 2 cubes? Isn't that just 3 of them out of 2? Same thing? Okay, so we know that it's 2 to the 3 halves. Check this out, guys. So isn't this just, oh, there we go, 2 to the 3 halves? So y, let's change it into exponential form. Here's my base. What's my exponent? Equals 2 to the 3 halves. This is the hardest one. Even harder than one here on your homework. How can I change this so this looks like this? How can I change this so it looks like this? Make it negative, so this is going to be 2 to the negative y equals 2 to the 3 halves. Is it that hard now? Okay, that's the hardest one. On your homework, this is y equals -3 halves. You should reference this in your homework. You're going to have that in your homework. Wow, you got through it. Like, with 30 seconds to start? All right, good job, guys.